Hello. Today we have our final topic in mechanics, pendulum, or pendula for the plural. And we'll look at kinematics first, just quick review of that. And by the way, we'll be changing to angular quantities because a pendulum twists through an angle theta as it swings back and forth. Then we'll look at forces, which again, because it's twisting through an angle, means that it is being torqued about the equilibrium, which is this vertical blue line. And then we'll look at energy. All right, so kinematics first. We do green for this one. All right, so for kinematics in standard simple harmonic motion, we started with a cosine omega t, where x is the distance away from equilibrium. Well, now instead of simply having a distance x, we have an angle theta away from equilibrium. So this x is going to turn into a theta as a function of time. And then we have the maximum angle through which it swings. So this theta over here should probably be called max, since from what I have drawn here, it's not going to go any farther above that angle. So that will be the maximum angle that it would twist through. And as we looked at before, if you take the derivative of position with respect to time, our cosine turns into a sine. That omega comes out by, what is that, the chain rule? Now with angular quantities, and this is going to be annoying, that theta turns into an omega. This omega, angular speed at any point in swing. That is different than this omega on the other side of the equal sign, that guy, which is 2 pi over the period, which is how often it goes through that swing. No, how many swings it does per second. I agree this is annoying. But we won't really worry about this guy much, because what we really care about is the second derivative, to give us the acceleration. And that sine turns back into a cosine. Another omega comes out by chain rule. And we have the same exact thing, but with angular quantities, the A turns into an alpha. Another omega comes out. And we still have theta max multiplied there. Now again, remember that the cosine and the sine both. The cosine taps out at -1 or 1. So max cosine value equals plus or minus 1, which means max A is omega squared A, and the maximum alpha is omega squared theta. Now when we get to torque, we're gonna do exactly the same thing that we did before to get rid of the acceleration and replace it with position and relate the left and the right side for torque. This is just the review of the quantities of motion for a pendulum, and now because the pendulum is twisting through an angle theta for a given time t, and you guys saw that during the lab, the pendulum swung back and forth through an angle, and there were a few people that pulled the pendulum, so they took this thing and they pulled it way up to the side, and I said, no, 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 don't do that, because you're going to mess things up for your data, and we'll see that in the notes. All right, I don't think I have anything else that I need to say about the kinematics of motion, so we can declare this guy pretty much done. We're going to care about that guy quite a bit.